Yesterday, we learned how to multiply binomials, right? So binomials by binomials. We learned 3 different methods. We learned how to do area diagram. We followed that up with something called distribution, and we followed that up with something called FOIL. Reality is distribution and FOIL are the same thing. Okay? You can choose whichever method you want to master. Okay? You have to have one of the methods just nailed down. I can do it every single question. They might give you a question where you have to use distribution, but they'll probably only give you 1 or 2. So you need to know how to do them all, but how to master one of them. Okay, so when you move forward in math, it's I can multiply anything. So I'm really good at area diagram or something along those lines. Before we do a question, we're going to look at this guy, x plus 7 squared. We're going to remember that we cannot do this. The reason we can't do that is because... Who remembers? Yeah. It doesn't work for polynomials, exactly. This is a plus sign in the middle, right? So you can't distribute. That only works for monomials, which is what we did in Unit 1, which is why it worked in Unit 1. That's awesome. Just keep not working. Instead, what we do is we say if we have a binomial or any polynomial squared, we scratch out the squared sign and we write it twice. Because that's what it means to have something squared, right? It means to have 2 of them. Awesome. This reminds us, we have x plus 7 times x plus 7. We have 2 binomials multiplied. We could use any of our 3 strategies. I'm going to do one of each before moving on to the next section. So we'll start off with area diagram. Area diagram, you take one of your binomials. We'll do this one. We write it across the top. You don't need to write the plus. You have x, you have 7, and it starts creating a grid for you. You take the other guy, and it goes down the side, x, 7. And that finishes building your grid. On the inside of the grid, you multiply the row and the column. So in this first spot right here, you have x times x becomes x squared. X times 7 becomes 7x. X times 7 becomes 7x. And 7 times 7 becomes 49. Right, so you fill out the middle of the grid. That is your result after you multiply the 2 binomials together. You then take that result, you write it out into a nice line. So you write out all the terms. We have x squared. Then we have plus a 7x. Then we have plus another 7x. And then we have plus a 49. In that polynomial, you might have something that could simplify, right? Like terms. That means you have the same letter with the same exponent. This right here and this right here are both 7x to the power of 1. That's like terms. So we add them together. You go 7 plus 7 is 14x. The other things could not combine. So your final answer would be x squared plus 14x plus 49. Fantastic. Rings a bell from yesterday? I hope so. We'll do the one right below it. 4 times negative 7x times 4 plus, 4 minus 7x times 4 plus 7x. This time we're going to use distribution. Okay, so distribution says that you take everything in the first brackets and it gets distributed into the second set of brackets. So when I take this 4 from the first set of brackets, I distribute that term to the first thing over there, which is another 4. 4 times 4 is 16. Then I distribute the 4 to the other thing as well. So 4 times 7x becomes plus 28x. But that's only the first term we've distributed. You need to distribute all the terms from the first set of brackets. So that means we also need to go take this negative 7x and distribute it in as well. So we get negative 28x. And negative 49x squared. distribution is probably the fastest way to multiply things, although people tend to miss one or two of the terms when they're doing all the distributing. Okay, so just be very careful if you do like this, that every term from the first set of brackets is going into every term on the second set of brackets. When you're done, you should have some like terms somewhere in there. We have some like terms right here. Right, we have plus 28x and negative 28x. You add those together to get 0x's. You don't actually write 0x. Right? This is like that example of them canceling out, is what you would have learned. I prefer to think of them as they just are equaling out to be 0, and we don't add 0. Right? I never put plus 0 on something. Your final answer is 16 minus 49x squared. Fantastic. We'll do the very last one, E. We're going to use FOIL this time. Okay, so you have a binomial times a binomial over here. We're going to do FOIL. Remember, FOIL is an acronym, and it's how you multiply your two binomials together. FOIL only works for binomials times binomials, which is why I don't ever use it. And the F stands for first, meaning you take your first terms and multiply them together. 2p times 2p would be 4p squared. O stands for outside. I like to think of it as like a sandwich. So you're talking about the outsides of the sandwich. This is my sandwich, the outside's here and here. That'd be negative 18p cubed. I means the inside of the sandwich. So if we're talking about inside of the sandwich, that would be right here and right here, which is another negative 18p cubed. And L stands for last, meaning the last term in each polynomial. The last term in each polynomial would be 9q and 9q. They're both negative 9q's, which would multiply to become positive 81q squared. You'll notice you then get four terms, right, which we're used to seeing. We're always getting these four terms, it seems. We write them all out. 4p squared minus 18p cubed minus another 18p cubed plus 81q squared. If you have any like terms there, you can combine them. We do have some like terms this time. We have negative 18p cubed and another negative 18p cubed. Those don't cancel out, right? You would go negative 18 plus negative 18, and you get negative 36p cubed. Notice that it stayed pq. It didn't change to p squared or anything crazy like that. When you're adding like terms, it's just the coefficients that go. The other terms stay the same. So we have 4p squared. And we have plus 81q squared. That's our answer. That's basically just a review of yesterday. Awesome. Now, let's see if we can apply that stuff to a little bit harder questions. We'll start things off with what to do when you have three things multiplied together. So if you look at this first question, you have a monomial times a binomial times a binomial. And there's different ways to tackle that, right? So different people might give you different strategies. Here's how I'm going to do it. The monomial is going to multiply into the brackets, but it's only going to multiply into the first set of brackets. Okay, so if you think about this, like some people want to take this 5 and multiply it to everything. Okay, and that would be correct. When you're multiplying regular numbers, so if I gave you like 2 times 3 times 4, and you went to multiply those together, you could go 2 times 3 is 6. 6 times 4 is 24. You wouldn't go 2 times 3, 2 times 4, and then multiply your answers together. Right? That would be a lot crazier. Instead, you just did the first two things, got an answer, and then multiplied it by the third thing. That's exactly what we're going to do with this. Right? It's the same idea, it's just polynomials. So we are going to multiply that 5 by the first binomial. We're going to get an answer, and then we're going to multiply that answer by the second binomial. Okay? The 5 multiplies by distributing it. We have 10x minus 15. The other one is still x minus 6. You'll notice I only multiplied it into the first set of brackets. Now I have a binomial times a binomial. That is something I can multiply together. You can use whatever method you prefer. All right, I'm going to use distribution. So 10x distributes to become 10x squared. Then it distributes to become negative 60x. Then I'm going to have to distribute the negative 15 in to become negative 15x. And distribute the negative 15 over there to become positive 90. 36 to 90. If you did area diagram or FOIL, you would get the same 4 terms I got. Right? Just organized it. You should be left with some like terms. Negative 60x minus 15x would be negative, 75x. There we go. And then the 10x squared is still left alone. And the plus 90 is still left alone. And that's my answer. 10x squared minus 75x plus 90. Awesome. You try the next one. Remember that this squared means that there's 2 binomials. So that's the first thing you would have to do. Then do what we just did. Monomial first, binomials together. Okay, so give it a shot. I'll show my answer after. Use whatever method you please. We're going to take the monomial, which is negative 8. We're going to distribute it in first. Okay, that'll give me another binomial, like a new one. When I go negative 8 times 7, that gives me negative 56p. When I go negative 8 times 3, I get negative 24. And that's still in brackets because I haven't multiplied it by the other binomial yet, which is 7p plus 3. Once you get rid of the monomial, you just got 2 binomials, right? So it's the same old, same old. You can use any method you want. If you use that method, you should come up with the same 4 numbers. Whoa, I'm going to need a calculator for mine. We're going to do 56 times 7. We get 392p squared. Negative 392p squared. That would be the first distribution. The next one would be negative 168. Oh, yeah. Thank you. Negative 168p. Then I distribute the negative 24 in. Oh, I need some love with that one.
Negative 168p.
Negative 168p again. Crazy. And the last one would be negative 72. Well done. Okay, so those are the 4 terms you should have got no matter how you chose to multiply these things together. If you use FOIL, you get those 4 terms. Use area diagram, you get those 4 terms. Use distribution like I did, you still get those 4 terms. Okay, maybe in different order, but you always get those 4. Your last step is to simplify and collect any like terms. You'll notice these are like terms. They're both p's. When I combine my like terms, my final answer would be negative 392p squared minus 36. Anybody do it? 36? Oh, miracles happen, people. P and then minus 72. And that's my final answer. Remember, I can't collect any further like terms because they all have different exponents, right? P squared, and then p to the power 1, and then a constant. Right? So those don't combine. People find this unit difficult. Actually, math in general gets difficult as we move forward because it's hard to know when to stop. Right? Like, when am I done the question? You're done the question when every variable has a different exponent. And that's when you're like, okay, I'm good. Right? P squared, p to the 1, no p's. Done. Can't do anything further. Awesome. That's how to deal with like monomials with multiple binomials. What to do if you have multiple binomials? So like something like these crazy shenanigans. The first thing to do is try to recognize where all your multiplication is going to be. Right? We still follow the bedmath rules that you learned years ago. So you need to know if there's any exponents that need to be dealt with, division, multiplication, addition, subtraction, and blah 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 blah. We recognize there's multiplication here and multiplication here. Okay? This is like two separate multiplication questions. And once you do those multiplications, they want you to subtract your answers. Okay? Take the blue one, subtract the purple one. The best way to do this, in my opinion, is to do the multiplication first, and then I'll show you how I tackle it from there. So we'll start with the blue one. If you had that guy, and you multiplied it using distribution, you would get x squared plus 5x minus 5x minus 25. Plus 5, negative 5, these two guys would cancel each other out, right? To become x squared minus 25. That's what the blue one would multiply to become. Then we have this big old subtraction sign still. The purple side. If I multiply the purple side together, I'm going to use distribution, right, like this. That would give me x squared plus 8x plus 2x plus 16. Run out of space, and go to the next question. Okay, so I distributed that. I got x squared plus 8x plus 2x plus 16. Again, I have some like terms. Right, so it's x squared plus 10x plus 16. And now I'm going to show you and talk about something really important. Okay, so I'm going to let you catch up, write those things down, and I'm going to show you the biggest mistake that happens on this question. Awesome. So I've multiplied my two different sides together. After I multiplied them, I said I wanted to subtract them, right? I highlighted the subtraction in red. I wanted to subtract the entire purple side. If you look at how I have the question written right now, I'm only subtracting the x squared. So what we need to do is put brackets around the purple side, so that I remind myself I'm subtracting the entire purple side. The way we subtract the entire purple side is we take this negative and we distribute it in to every single term. This gives me x squared minus 25. Once I've put that negative in there, I now have negative x squared, negative 10x, and negative 16. So make sure that if you have a negative on the outside and you're subtracting away, that negative has to end up going to every single thing. If it was a plus, we don't have as much of a problem, because when you multiply a plus in, it stays the same. But the negatives cause you issues. Okay. At this point, I should have some like terms I can collect. If you look, I have two that are both x squared. I have a plus x squared and a minus x squared. Those cancel out or equal 0. I then have a 25, negative 25, and a negative 16. Those could combine to become negative 41. And then I have a negative 10x. My answer would be negative 41 minus 10x. If you reverse the order and put negative 10x minus 41, that's the exact same solution. Right? You can reorder addition and subtraction. All right, I took up our space a little bit over here, but I'll try to do this one too. You go ahead, give it a shot, see if you get it right. Make sure you deal with this squared first, right? Get rid of the squared. Make it 6a minus 5. Okay, and try to answer that. Try to break it up a little bit so I don't get crisscrossed here. B. All right, we're going to follow the same strategy we did last time, which is going to be multiply the two binomials together, multiply the other two binomials together, then subtract the results from each other. When you do that, this guy right here, you're going to multiply those together. 9a times 4a would have become 9, 18, 27, 36a squared. Then you would have distributed it to the negative 9, so you have negative 81a. Then the 4 comes in to become plus 16a. And then it goes in to become negative 36. Yeah, there's no way I'm fitting that. I tried my absolute best. Then you have that big old subtraction sign, right? So then you have to subtract. Your answer from when you multiply the next two things together, these guys. When you multiply those guys together, I'm just trying to think of how I can neatly put my answer. The answer is I can't. You should get, actually this is what I'll do. I'll simplify the blue guy all the way down. We have 36a squared. Hello, Mr. Marshall. And then 81 plus 16. Who hit me with that? You know. 65. Mr. Marshall's got me. Negative 65, eh? And then negative 36. And then you have that big red subtraction sign, right? So that you don't forget it. The purple side, because I'm going to run out of space, you would have got the same four terms as me no matter what method you use. Right? You would have had 36a squared, and you would have had 2 minus 38s, and then you would have had a plus 25. But you should have come out with something that looks like this. 36a squared minus 60a plus 25. Oh, I just ran out of space. And the key to the question is that the purple stuff has to still be in a set of brackets, because that big red negative sign has to apply to the entire purple side. It has to go to all three terms. If you don't put the set of brackets there, then the negatives only go into the first term, and then you're not actually subtracting the entire polynomial away. Okay, so check your paper, check to see if you actually took the negative and distributed it into all three things. If you did, you would have ended up with 36a squared minus 65a minus 36, so the blue side doesn't change, and then minus 36a squared minus 60a minus, plus 60a, sorry, and then minus 25. I almost fell for the own trick I told you not to fall for. Those are the 6 terms you should have had on your paper after you did all of your simplifying. Right? No matter what strategy you use, if it was FOIL, distribution, if it was area diagram, you should have always ended up with these things. Our goal then is to collect any like terms. Remember, like terms means same letter, same exponent. 36a squared and negative 36a squared, we've seen that before, it equals 0. We have negative 65a plus 60a. We put that in our calculators, just the coefficients, right? So negative 65 plus 60, and you get negative 5a. And then you do your constants, negative 36 minus 25, from negative 61. Again, if you reverse those, you put negative 61 minus 5/8, that's the same answer. Right? It's just different order. Awesome. How people do with that one? Decent? That's a hard one. And you will see stuff like that too, right? Like it's not going to go away. That'll be one of the more challenging questions on a test. And just take your time with it, right? You'll always have lots of space to work on your test. And if you don't, come get scrap paper. So I keep a whole stack of it for questions like that. It takes a lot.